Hello and welcome to this Python tutorial. So before we take the challenge to improve our relevance accuracy of 83% that we just computed in the previous tutorial with k-fold cross-validation, I'd like to cover a very important technique in deep learning, which is the dropout regularization. So the dropout is the solution for overfitting in deep learning. Overfitting is when your model was trained too much on the training set, too much that it becomes much less performant on the test set, and we can observe this when we have a large difference of accuracies between the training set and the test set. Generally, when overfitting happens, you have a much higher accuracy on the training set than the test set. And another way to detect overfitting is when you observe a high variance when applying k-fold cross-validation, because indeed, when it's overfitted on the training set, that is when your model learned too much, well, sometimes it will succeed on new observations in one test set, when the correlations are similar to what the model learned too much, and sometimes your model won't succeed on other test sets because the correlations that it learned too much unfortunately don't apply to these test sets. And therefore, in your vector of accuracies that you obtain with k-fold cross-validations, you have some high accuracies and some low accuracies, and therefore you have high variance, and that's how you detect overfitting. So we definitely didn't get overfitting in the previous tutorial, because indeed when we look at our vector of accuracies, we get our 10 accuracies with a very small variance, that is by the way equal to 0.9%, so that's a small variance, and as you can see, our accuracies are more or less around 83%, the relevant accuracy that we obtained with k-fold cross-validation. But just in case you use the deep learning models you learn in this course on your datasets to accomplish your goals, and you observe some overfitting or high variance, well, I want you to have the solution to solve this problem. And this solution is the dropout regularization. So simply, in this tutorial, we will implement dropout. And so how does it work? Where do we need to apply dropout to our artificial neural network? And how does it work? Well, dropout works this way. At each iteration of the training, some neurons of your artificial neural network are randomly disabled to prevent them from being too dependent on each other when they learn the correlations, and therefore, by overriding these neurons, the artificial neural network learns several independent correlations in the data, because each time there is not the same configuration of the neurons. And the fact that we get these independent correlations of the data, thanks to the fact that the neurons work more independently, that prevents the neurons from learning too much, and therefore that prevents overfitting. Okay, so that's how it works, and now let's see how we can implement dropout within this implementation of our artificial neural network. Okay, so first we need to import a new class besides the sequential class and the dense class. This class is the dropout class. Very simply, so we import this class from keras.layers, same as for dense. And from this layers module, we import dropout. All right, so that's dropout. We can actually try to import it. Here we go, dropout imported. And now, where exactly in the neural network are we going to apply dropout? So as you understood, dropout is applied to the neurons so that some of them randomly become disabled at each iteration. And so basically what we need to do is to apply dropout to the layers. It can be to one layer, or it can be to several layers. So just to show you I'm going to apply it to several layers, I'm going to apply it to the first hidden layer, and I'm going to apply it to the second hidden layer. And my advice is that when you have overfitting, you should apply dropout to all the layers, because that will give you more chance to reduce overfitting. Alright, so let's apply dropout to the first hidden layer. So I'm going to add here with dropout, and we're going to add a new line right after we added the hidden layer with the dense function. And actually that's very simple. We take our classifier, then dot, and then again add, because we're actually adding dropout. And in the add function, you probably guess what we're going to input. Well, of course, we have to input dropout, parenthesis, and now we have several arguments. So let's inspect dropout by pressing Command or Control I, and let's have a look at the arguments. Okay, so the first argument is p, which is a float between 0 and 1, and that's the fraction of the input unit you want to drop. So basically that's the fraction of the neurons you want to drop or as I said, disable, at each iteration. So let's suppose we have 10 neurons. Well, if we choose p equals 0.1, 10%, then that means that at each iteration, one neuron will be disabled. If p equals 0.2, two neurons will be disabled. And so, which value of p should we input? Well, my advice is that when you have overfitting, that you start trying with p equals 0.1, 10%, and then if it doesn't solve the problem, if you still have overfitting, then you try a higher value of p, and you increment it, for example, by 0.1. So you first try with 0.1, and then if you still have overfitting, you try with 0.2. If you still have overfitting, you try with 0.3, and until you manage to reduce overfitting. Because of course, when you reach 1, all your neurons will be disabled, and then what you'll get is not overfitting, but underfitting, because nothing will be learned. There will be no neurons to learn anything. So in general, don't try to go over 0.5, because then you'll get too close to underfitting, and so what I recommend is to try with 0.1, then try 0.2, 0.3, 0.4, and that should do it. So here, just to give you the start, I'm going to input here p equals 0.1, and that's your first try. Alright, and that adds dropout to your first hidden layer. And then, very simply, if you want to apply dropout to your other layers, for example the second hidden layer, well, that's very simple. You just paste that here and you don't change anything. That's exactly the same. You add dropout here to your second hidden layer and you specify that you want to override, disable 10% of the neurons in the second hidden layer at each iteration. Alright, so now you know what to do in case you have to deal with overfitting. And now we're going to get to the fun part, which is parameter tuning. This is going to be the real deal about improving your model's performance, because basically we're going to tune our model and we're going to find the best hyperparameters, like the best number of epoch, the best batch size, the best optimizer, so that we get the best artificial neural network that will allow us to reach that 86% accuracy and make our challenge successful. That's exactly what we're going to do in the next tutorial, and until then, enjoy deep learning!